Hello everyone. So today we will continue with the examples of comparison test. So example 1. Test the convergence of the following series. 1 upon 1 into 2 into 3 plus 3 upon 2 into 3 into 4 and so on. So first of all, from this series we can find out un. So un will be, here in the numerator part we have terms 1, 3, 5, 7 and so on. So we can write it 2n minus 1, that is our numerator will be of the form 2n minus 1. Because whenever you will put 1 here, then only you will get 1. 2 minus 1, 1. If you will put 2 here, n equal to 2, then you will get 3. If you will put n equal to 3, then you will get 5. So our numerator will be 2n minus 1. And now we will see the denominator part. For denominator, we can see that the first term of the denominator is n term. 1, 2, 3, 4 and so on. So our first term will be n. Then second term is 2, 3, 4. That is one term is added. That is n plus 1. We can write n plus 1. And then we have 3, 4, 5. That is two terms are added in the nth term. So we will get n plus 2 here. So our un will be 2n minus 1 upon n into n plus 1 into n plus 2. So now we will find Vn according to comparison test. What will be the Vn? That is the n terms from the numerator part and the denominator part. In the numerator part we have only one n, and in the denominator part we have 3 n's, that is n cube. So we can write 1 by n square. So our Vn is 1 by n square. So now according to comparison test, if we take the ratio of un by Vn, then we will get 2n minus 1 upon n into n plus 1 by n plus 2 and divided by 1 by n square. So we can rewrite this equation as n square into 2n minus 1 upon n into n plus 1 into n plus 2. Okay? So now if we take n terms common from the denominator part, then we will get n square. And here also in the numerator part we can take this n outside. So we can write 2 minus 1 by n divided by, here also we will get 1 n is already there, and if we take this both 1 outside, then we will have n cube outside the bracket. So we will get n cube into 1 plus 1 by n into 1 plus 2 by n. Okay? So આવી રીતના આપણે n terms numerator અને denominator part માંથી common લીધી. So now this n cube and this n cube will get cancelled. And now according to comparison test, if we put the limit, that is limit n tends to infinity in the equation un by vn, then we will get, here we have to put limit n tends to infinity, then we will get 2. Okay, because here 1 is there. So we got finite and positive value. Okay? And as we got finite and positive value, we can write that both the series, that is both un and vn, will be either convergent or divergent. They can be convergent or divergent, but it can be decided based on the vn. Okay, so we will find vn according to p test, and whatever will be the vn, that will be the value of un. So we have vn, that is 1 by n square. So again our p is 2 and 2 is greater than 1. So vn is convergent. And as vn is convergent, vn is equal to un, so un is also convergent. Okay, so answer of this example will be convergent. Okay. So now example 2. 1 into 2 upon 3 square plus 4 square plus 3 into 4 upon 5 square into 6 square and so on is given. Now again from this series we can find out un. So what will be our un? Un is equal to, here we have terms 1, 3, 5 and whenever we have 1, 3, 5 term we can write 2n minus 1 as we have written in the previous example also. In that example also 1, 3, 5 terms were there. So here we can write 2n minus 1 and 2, 4, 6, that is they are the multiples of 2. So we can write 2n, and in the denominator part we have 3 square, 5 square, 7 square. So it is 2n plus 1. Okay, so 2n plus 1 whole square term. That is whenever you will put n equal to 1, you will get 3 square. Whenever you will put n equal to 2, you will get 5 square. So we can write here 2n plus 1 square. And now 4 square, 6 square and 8 square. That is 2n plus 2 whole square. Okay, so here also whenever you will put n equal to 1, you will get 4 square. Whenever you will put n equal to 2, you will get 6 square. So in this way you have to find un from the given series. Now we will assume vn. So let vn equal to, we will take all the n terms from the denominator part as well as numerator part. So in the numerator part we have n square and in the denominator part we have n raised to 4. So we will get 1 by n square again. So our vn is 1 by n square. Now again according to comparison test, if we take the ratio of un and vn, then we can write like this. N square will go in the numerator part. So 2n minus 1 into 2n divided by 2n plus 1 whole square into 2n plus 2 whole square. Okay. So now un and from this we can take this n terms common. So we will get here n square, and again if we take n common from this term, then we will get here 2 minus 1 by n and into 2n. Again here also in the denominator part, if we take n common, then we will get 2 plus 1 by n whole square, and here also 2 plus 2 by n whole square. Okay. So this n and this n will get cancelled. Sorry, here we can take I forgot to write here n square term we took common. Okay, so we have to write n square outside. So this all terms will again get cancelled. And so we will get 2 minus 1 by n upon 2 plus 1 by n whole square into 2 plus 2 by n whole square. Okay. And now if we put the limit according to comparison test in the term, then we get limit n tends to infinity un by vn. But what is our un by vn? That is this term. 2 minus 1 by n divided by 2 plus 1 by n whole square into 2 plus 2 by n whole square. Okay. So if we put limit here, then we will get, sorry, we also have this 2 here left. Okay. So here also 2 will get. If we put limit here, then we will get 2 into 2, because this term will be 0. Again this term will be 0 and this term will be also 0. So 4 into 4. 4 by 4 into 4, that is 1 by 4. Okay. So again here we got finite and positive value. And as we got finite and positive value, we will find Vn, and whatever will be the value of Vn, If Vn is convergent, then Un will be also convergent. If Vn is divergent, then Un will be also divergent. So we will find Vn. Vn is 1 by n square. So again P is 2 and 2 is greater than 1. So again it is convergent. And as Vn is convergent, Un is also convergent. So answer of this question is convergent. Okay. So example 3. Summation n equal to 1 to infinity under root n minus 1 upon n square plus 1 is given. So now from this we can say that our Un is under root n minus 1 upon n square plus 1. And what will be our Vn? We can write Vn equal to, we can write under root n as n raised to 1 by 2. And here we have n square. So we can write Vn equal to 1 by 2 minus 1 by 2. Okay. If we take this term in the denominator part, then we will get this term. And it means that our Vn is n raised to 3 by 2. Okay. So we got Un and Vn. So now according to comparison test, if we take the ratio of Un and Vn, then we get under root n minus 1 upon n square plus 1, and this n raised to 3 by 2 will be in the numerator part. So we will get, if we multiply these terms, then we can rewrite this equation as n square minus n raised to 3 by 2 upon n square plus 1. Okay. And now if we take n square common from the numerator part and denominator part, then we will get 1 minus 1 by n raised to 1 by 2 divided by 1 plus 1 by n square. Okay, now this n square and this n square will get cancelled. And now if we put limit in this equation, then we get limit n tends to infinity of 1 minus 1 by n raised to 1 by 2 upon 1 plus 1 by n square. Then we will get answer 1. Okay. So we got finite and positive value. And as we got finite and positive value, we can say that whatever will be the value of Vn, that will be the value of Un according to comparison test. So we will find the value of Vn. So what is our Vn? Vn is 1 by n raised to 3 by 2. Okay. So 3 by 2 is that is 1.5, and again P is 1.5, which is greater than 1. So Vn will be convergent. And as Vn is convergent, Un is also convergent. So answer of this question will be convergent. Okay. So example 4. Summation n equal to 1 to infinity under root n plus 1 minus under root n is given. Now here if we want to apply comparison test, then we should have denominator part. Here denominator માં કઈ આપેલું જ નથી. So in order to get denominator part, we will apply conjugate here. So we can write Un equal to n plus 1 minus n, and we will multiply and divide by n plus 1 plus under root n. Okay. That is, we will take the conjugate in order to get Vn term. Okay. And if you will solve it further, then you will get Un equal to 1 by n under root n plus 1 plus under root n. Now from this we can get Vn equal to 1 by under root n. Okay, because root n plus root n is 2 root n, but our Vn will be 1 by root n. And now according to comparison test, if we take the ratio of Un and Vn, then we get Un by Vn equal to under root n upon under root n plus 1 plus under root n. Okay. And if we take under root n common from the denominator part, then we will get under root n upon under root n. If we take common, then here we will get 1 plus 1 by under root n plus 1. Okay. Now this and this term will get cancelled. So we will get this term. And now according to comparison test, if we put limit n tends to infinity in this equation, then we will get 1. Again we got finite and positive value. Sorry, if we put the limit here, then here we have 1 in the numerator part, and in the denominator part this will be 0, but 1 plus 1 will be 2. So we got 1 by 2. Okay. So again we got finite and positive term. Okay. So whatever will be the value of Vn, that will be the value of Un. So we can write that here Vn will be equal to Un according to comparison test. Okay. So Vn is equal to 1 by under root n. That is 1 by n raised to 1 by 2, and value of P is here 1 by 2, that is 0.5. So we can say that here P is less than 1. And whenever P is less than 1, answer is divergent. So our Vn is divergent, and as Vn is equal to Un, Vn is divergent, Un will be also divergent. So answer of this question will be divergent. Okay. So example 5. 2 upon 1 raised to p plus 3 upon 2 raised to p plus 4 upon 3 raised to p and so on is given. Now from this series we can find out Un. So Un will be, here we can see that here all natural terms are not there, but we have 2, 3, 4. It means that it is 1 plus 1. 2 plus 1, 4, 3 plus 1. That is, we can write that it is of the form n plus 1. Okay. Numerator part is of the form n plus 1. And here we have n terms. So we can write n raised to p. And now from this we can find Vn. Vn will be n by n raised to p. So we can write 1 by n raised to p minus 1. So this is our Vn. And now as we got Un and Vn, we will take the ratio of it and put limit. So Un by Vn is equal to n raised to p minus 1 into n plus 1 upon n raised to p. But we can rewrite this n raised to p minus 1 as n raised to p into n raised to minus 1 into n plus 1 upon n raised to p. So this and this term will get cancelled. So we will get n plus 1 by n. And if we take n common from the numerator part, then we will get n into 1 plus 1 by n upon n. Again this n and n will get cancelled. And now as we got final value, we can put limit according to comparison test in Un by Vn form. So limit n tends to infinity of Un by Vn is 1 plus 1 by n. And if we put limit here, then we will get 1. So as we got finite and positive value, whatever will be the value of Vn, that will be the value of Un. So what is our Vn? Vn is 1 upon n raised to p minus 1. But here Vn is 1 upon n raised to p minus 1. So whenever p minus 1 will be greater than 1, and that is if we take p greater than 2, if we take here 2, 3, 4, 5, then during that time we have to assume values. Okay. So you have to take two conditions. First of all, whenever p minus 1 is greater than 1 and whenever p minus 1 is less than or equal to 1. પણ p minus 1 greater than 1 ક્યારે થાય? કે જ્યારે p 2 થી વધુ હોય. જો 2 મૂકશું તો 2 minus 1 તો 2 minus 1 1 ને equal થઈ જશે. But we have to put p greater than 2. That is, if we put 3 here, then we will get 2, which is greater than 1. If we put 4 here, then we will get 3. So during that time, this condition will satisfy. Now, p minus 1 less than or equal to 1 ક્યારે આવે? કે જ્યારે આપણે p ની વેલ્યુ less than or equal to 2 put કરીએ. For example, if we will put p equal to 2 here, then we will get 2 minus 1, that is 1. Okay? So our conditions satisfy થવા જોઈએ. Okay? So જ્યારે કોઈ પણ આવું ફોર્મ આપેલું હોય તો ત્યારે આ બે કન્ડિશન્સ જે p ટેસ્ટના છે કે p minus 1 greater than 1 ક્યારે થશે અને p minus 1 less than or equal to 1 ક્યારે થશે અને પછી કઈ વેલ્યુઝ માટે થશે એ પુટ કરી દેવાનું. So answer of this question will be, so given series will be convergent for, so it will be convergent for p greater than 2. Whenever p will be greater than 2, it will be convergent. But whenever p is less than or equal to 2, it will be divergent. So we can write, but whenever p is less than or equal to 2, the series is divergent. Okay, so here we get two conditions, that is whenever p is greater than 2, the series will be convergent, but whenever p is less than or equal to 2, the series is divergent. So example 6, summation n equal to 1 to infinity 1 by n into sine 1 by n. Now here also we cannot apply, હવે આપણને જોઈને એમ લાગે કે સમેશન n equal to 1 થી ઇન્ફિનિટી આપ્યું છે તો nth ટર્મ ટેસ્ટ અપ્લાય કરીએ, પણ એ અપ્લાય ન થાય. કેમ કે જ્યારે તમે અપ્લાય કરશો લિમિટ n ટેન્ડ્સ ટુ ઇન્ફિનિટી, આ જે આપણું un છે એમાં પુટ કરશો, then its value will be 0 because sin 1 by infinity is 0 and we will get answer 0. તો n ટેસ્ટમાં શું હતું કે જ્યારે n 0 આવે તો ત્યારે બીજી ટેસ્ટ અપ્લાય કરવી પડે, પણ એ નોટ ઇક્વલ ટુ 0 આવે then you can directly say that whether it is divergent. But here we are getting n equal to 0, so we cannot apply nth term test. So we will apply comparison test. Okay? So again we have un equal to 1 by n sine 1 by n. Okay? But we know the formula of sine theta. Sine theta is theta minus theta cube by 3 factorial plus theta 5 raised upon 5 factorial and minus theta 7 by 7 factorial and so on. So this is the formula that you have to remember. You should know, I think you know all. So now if we put this value of sine theta, this is our theta. So instead of theta here it is 1 by n. So here we can put this value. So we will get 1 by n into 1 by n minus here 1 by n whole cube upon 3 factorial. That is 1 by 3 factorial into n cube plus 1 by 5 factorial into n raised to 5 and so on. Okay? So this is our un. Now what is our vn? Then vn will be 1 by n square. Okay, vn છે એ તો આ મેઇન ટર્મ માંથી જ આપણને ખબર પડી જશે કે vn is 1 by n square. So if we take the ratio of un and vn, then we get આ જે n square ટર્મ છે એ આની સાથે ઉપર ન્યુમરેટર પાર્ટમાં જતી રહેશે. So we will get 1 minus 1 by 3 factorial into n square plus 1 by 5 factorial into n raised to 4 and so on. જ્યારે આપણે આ un અને vn નો રેશિયો લેશું તો n સ્ક્વેર અહીંયા ઉપર જતું રહેશે એટલે આ ને આ કટ થઈ જાય એટલે અહીંયા 1 આવે. એવી રીતના અહીંયા n સ્ક્વેર વધશે, અહીંયા n4 વધશે and so on. Okay? So you will get un and un by vn. Now if we put limit in this equation, then we will get, if we put limit here, then this all the terms will be 0. Only this 1 will remain. So answer is 1. And as we got finite and positive value, According to comparison test, whatever will be the value of Vn, that will be the value of Un, and again Vn is here 1 by n square and 2 is again greater than 1, so Vn is convergent. And as Vn is convergent, Un is also convergent, and so answer of this question is also convergent. Okay? So example 7. Test the convergence of summation n equal to 1 to infinity 1 by 1 square plus 2 square plus 3 square up to n square is given. પણ આમાં આપણને n સ્ક્વેર સિરીઝ આપી છે ડાયરેક્ટલી, તો આપણે n સ્ક્વેર ની તો ખબર જ છે ફોર્મ્યુલા. That is, we can write n by 6 into n plus 1 into 2n plus 1. We know the formula of n square, okay? So here in place of this whole series, we can put this value. Okay? So our un will be 1 by n by 6 into n plus 1 into 2n plus 1. Okay? So we can rewrite this series that is 6 into n, 6 by n into n plus 1 into 2n plus 1. So this is the value of un. Now what will be the value of vn? Then vn will be 1 by n cube, because here there are, in the numerator part there are 3 n's. So vn is 1 by n cube, and now taking the ratio according to comparison test, we will get un by vn, that is 6n cube by n into n plus 1 into 2n plus 1. Okay? And if we take n cube common from the numerator part, then we will get 1 plus 1 by n and 2 plus 1 by n. Okay, so this n cube and n cube will get cancelled. And now if we put limit n tends to infinity in un by vn, that is in this term, then we will get its answer as, here we will have 6 in the numerator part and in the denominator part 2 will remain. So that is equal to 3. So answer will be 3, and as we got finite and positive value, according to comparison test, whatever will be the value of vn, that will be the value of un. So what is our vn here? Vn is 1 by n cube. Okay? So again our p is 3 and 3 is greater than 1, so our vn is convergent. Okay, and as vn is equal to un, according to comparison test, un is also convergent. So answer of this question will be convergent. Okay? So in this way, you have to solve the examples of comparison test. Now these are the examples for practicing. 4 examples are there based on the comparison test. Okay, do practice these examples. Thank you everyone. I hope you all liked my video lecture. Thank you.